Today we are verifying trig identities, and I do want to put out here, this is very similar to what we've already been doing. It's just in a slightly different form. That is it. So the good news is, I think after these notes for some of you, it's going to click a little more. And also, you're going to find these easier than the other problems, especially if you've already got the other problems. You're really going to like these. So I'm going to give you a couple of instructions first, or some guidelines to follow, if you will. First off, with these problems, your ultimate goal, these are equations, by the way. Your ultimate goal is get the same thing on the left and right sides of the equation. That is all we're doing here. Make the left and the right sides match. How we're going to do this? Simplify the trig expressions on either side until they match. More specifically, how you use the steps on the slider. To give you more of an idea of what we're doing, I'm going to show you a very basic connection to algebra, what this looks like, but obviously it's going to be with trig. But this is just to drive home the point of what we're doing. You don't have to write this part down if you don't want to, unless you find it helpful. Essentially, what we're doing here would be similar to if I gave you the equation 2x plus 1 equals 9, and I asked you to verify, show that x is 4. Now we won't solve for x, we're going to plug the 4 in and show that it actually works. That's what we're doing here. So just to compare real quick. So we'd have 2, plug in the 4, 2 times 4 plus 1 equals 9. For clarity, we are not plugging anything in for our actual problems, but the end result here, that's what I'm going for. So we know 2 times 4 is 8, plus 1 equals 9, and then 8 plus 1 we also know is 9. This right here, this is what we're aiming towards, is to get that equality on both sides. And that's done by simplifying the sides of the equation until they're equal. Sometimes you'll simplify just the left side, sometimes it will be the right side, sometimes it'll be both. Depends on the problem, and it depends on your approach. So again, this is our goal here. We're not going to stop one step short, and you'll be like, well, I already know 8 plus 1 is 9. Great. Go one step further. Verify, show, state, yes, 9 equals 9. That's true. All right, first example. Oh, before I write this down, one major rule. I'm going to write this on every single problem that I do. Do not cross the middle line. Just for comparison, when I say that, Yes, we have an equation, but we're not doing algebra in the sense that we're moving things back and forth from one side to the other. Notice I managed to get to this conclusion without moving anything over. Same thing applies to these trig problems. Don't move anything like that. First example, this one's going to be a short one. We have the equation sine squared x over cosine squared x equals secant squared x minus 1. Reminder, don't cross. So we have options here. We can simplify the left to match the right. We can simplify the right to match the left. It is really, again, a personal choice. It's whatever catches your eye first. And like I said, there are multiple approaches. For me, the sine squared over cosine squared, I can already work with that. I know that's tangent squared specifically, because sine over cosine is tangent. So first thing I'm going to do is replace that with tangent squared x equals secant squared x minus 1. And if you look on the slider, that's true. Tangent squared is equal to secant squared minus 1. But again, this would be stopping the one step short. You could be like, well, I know that that's true. Again, actually get the same thing on both sides. So you can do one of two things. You can replace the tangent squared with the secant squared x minus 1 so that it's equal that way. Or you can replace the secant squared x with the tangent squared x. They're both going to be correct. Their answers are going to look like two different results, but they'll still be true. So I'm going to keep going on that left side, and I'll replace that tangent squared x with what it's equal to. Secant squared x minus 1 equals secant squared x minus 1. That's a true statement. We are done. So what's really nice and convenient about these problems is you technically already have the answer. You just do work until the sides match. That's it. The other problems, obviously we give you the answers on the worksheet. We can't do that on the test. So when you're doing those problems and you don't know what the answer is, you're not sure if you're done. You're not sure if you've done enough to get there. You're not sure if your work is right, that kind of thing. There's a little more of a safety net. So a lot of students really like these problems. Questions on our first problem? Yes. Yep, you could have alternatively changed. That's actually what I did yesterday. Let me pull those notes real quick. So I did the opposite yesterday where I replaced the right side and did tangent squared, tangent squared. That's also correct, yes. Yep. Those are the two ways. Actually, there's another way it could turn out, but most students go that way. So yeah, you have options. Make sure they're the same, both sides. Next problem. This one we're going to kick it up a notch. We have 1 plus sine of x over cosine of x equals cosine of x over 1 minus sine of x. Friendly reminder, don't cross. Because I know it'll be tempting to. Fractions. When you have two equal fractions, obviously the tops and the bottoms must match. So the easiest way to start the problem is get the same denominator. Once the denominators are the same, then you can focus all of your attention on getting those top terms to match while carrying the denominator through the full answer. So that's where I always start. We have cosine of x on one and 1 minus sine of x on the other, so obviously I can't turn one into the other, so I'm going to do a nice switch here. Multiply the left fraction by 1 minus sine on top and bottom. I'll use parentheses since that's an expression. Multiply the right fraction by cosine over cosine. For the left one, I'm just going to put it together first, since I'm going to have a FOIL problem on top. So we have 1 minus sine of x times 1 plus sine of x all over our denominator, 1 minus sine of x times cosine of x equals. Right side, since it's just a simple multiplication on the top, I'll go ahead and do that. That's going to give me cosine squared x over our denominator, 1 minus sine of x cosine of x. We have equal denominators. Now we focus on getting equal numerators. So 1 minus sine, 1 plus sine, we can FOIL that. If you notice right out of the gate that this is a difference of squares, then you can skip ahead to the final result from there, but I will FOIL it out fully. By the way, when you have fractions, leave a bit of space between the steps so that the fractions don't run together, especially when I'm grading your test. That's going to make it easier for me. Go ahead and copy down the denominator, 1 minus sine of x cosine of x. On the top, FOILing, 1 times 1 we get 1. 1 times positive sign, that's a positive sine of x. Negative sign times 1, that's negative sine of x. Negative sign times positive sign, that's negative sine squared x. From here, I hope you notice that the middle terms, we have a plus sign and a minus sign. This is like a positive one and a negative one. They will cancel each other out. So these are gone. So we end up with just 1 minus sine squared x over 1 minus sine of x cosine of x. Since the right side didn't change, I'm just going to arrow down and rewrite it again down here. Cosine squared x over 1 minus sine of x cosine of x. I hope you guys can see the finish line from here. 1 minus sine squared equals cosine squared. That is one of our identities right here. That's a true statement. Reminder, you do have to change one of them so that they match completely. So just to keep things simple, I'm going to replace the 1 minus sine squared with the cosine squared, and they will match perfectly. So that's going to be my final step. Cosine squared of x over 1 minus sine of x cosine of x. And then I'll write that again over here. Cosine squared of x equals 1 minus sine of x cosine of x. Again, once you have the same thing on the left and the right, you know you're done. That's the ultimate goal. Questions on example number 2. Example 3. You'll like this one, it's shorter. we have cosine of x over sine of x tangent of x. Nope. Cotangent. Hold on, let me fix that real quick. I just saw the t on my paper and assumed it was tangent. Okay, let's rewrite that. There we go. Equals 1. Friendly reminder, don't cross. Now, when you get just 1 on the right side, you don't have much to do with that at all, because there's a lot of options that equal 1 on this slider. So obviously the right side can't change at all. We need to somehow, some way turn this into 1. So we're going to work with the left side till we end up with 1. We have cosine over sine cotangent. Sine cotangent, there's multiplication there, but those are not reciprocals. Sine and cosecant are, so we can't do that. So our only option from here, since there's no Pythagoreans, is to go straight to changing to sine and cosine. The only term that needs change is cotangent. So we end up with cosine of x over sine of x. And then I replace cotangent with its identity, its reciprocal identity. Reminder, pretty much every time use cosine over sine. There's a couple times you might want to use tangent, 1 over tangent instead, but if you're ever not sure, always use the cosine sine identity. Now we have a term multiplied by a fraction. I'll put this over 1 so we can clearly see what those fractions are. Since this is multiplication here, yes, multiplication, and we have 1 on top and 1 on bottom, sine and a sine, we can cancel. That's allowed. Again, cancel through multiplication, not addition or subtraction. Now those are both going to become 1s. So we end up with cosine of x over, we just end up with cosine over 1, so cosine of x. And when you end up with the same trig term or number on the top and the bottom of a fraction, of course, when you divide something by itself, it will become 1. So these cancel out completely, and you just get 1. Bring that 1 down. 1 equals 1. That's a true statement. You're done. Questions on example 3? I've got one more and then I'll let you work. Example 4. Secant x plus cosecant x times cosine of x minus sine of x equals cotangent of x minus tangent of x. Reminder, don't cross. This looks like a monster of a problem. It's really only a few steps. So, we can go through the basics, steps 1 and 2. Multiplication identities. Outside of actually multiplying these, we don't have that yet. Pythagoreans, your squareds, no squareds present. So we're going to jump straight down to step 3. Change everything in terms of sine and cosine. We have several things to change. So first, the secant, that is 1 over cosine, plus the cosecant is 1 over sine, times cosine of x minus sine of x, equals, right side I will also be changing. Cotangent is cosine of x over sine of x, minus tangent is sine of x over cosine of x. Reminder on the right side, this is subtraction, so we're not going to cancel and call that 1. That's not how we subtract fractions. Now on top of that, while I'm on the topic of that for the right side, there's stuff you can do here. You can get a common denominator, combine like terms, blah, 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 blah. That's a lot of work. So clearly there's a lot of work to be done on the left side. I wouldn't also dive in and try to do all that work on the right side as well. This I would kind of wait and see what happens. If you have to later go in and do more work with these, then do that. But for now, I would leave these alone. Because again, the goal is just to get the same thing on the left and the right side. And you can get there with a little work or a lot of work. It just depends on your approach. So I would choose one side to pick apart at a time, especially when there's a lot going on. And that side clearly has to be the right side. The left side. There's a lot going on here. Now that I've changed things out, I can FOIL these together. So we have 1 over cosine times cosine, and this is cosine over 1. Now these are reciprocals. They are going to cancel each other out. That's going to give us a 1. 1 over cosine times negative sine over 1. So we're just going to multiply straight across. So we have, this is going to be a minus first off, since it's negative. 1 times sine, that's going to be sine on top. And then cosine times 1, so cosine on the bottom. And now let's FOIL the 1 over sine. 1 over sine times cosine over 1. We're going to have cosine on top and sine on bottom, positive. And then 1 over sine times negative sine over 1. So first off, this is going to be negative. And then 1 over sine times sine over 1. Again, reciprocals, those will cancel. We'll get just a 1 there. If you want to manually write out sine over sine first and then change it to a 1, that's always doable. It's always acceptable. From here, we have a positive 1 in front and we have a negative 1 in back. Those will cancel each other out. And let me bring this down real quick. Don't leave that negative up there. Negative sine of x over cosine of x plus cosine of x over sine of x. Careful with those signs. I'm going to bring down the right side now. Cosine of x over sine of x minus sine of x over cosine of x. I hope you see that these are the same thing, they're just switched. So one of the sides has to be flipped. You either flip the left side or you flip the right side. Choice is yours. I prefer to have the negatives in the back, that's me. So I'm going to switch these two on the left side to make this work. Again, be careful with the signs. So we're putting the cosine over sine first. And it's positive, so it'll stay positive. And then the negative sine over cosine, so that'll become minus sine of x over cosine of x. And then I'll bring down the right side. Same thing on the left and the right, so I can stop here. Like I said before, you could keep going, you get common denominator, and then combine the fractions, but there's no point in that. You've done enough work to show that these are equal. So unlike the other problems where you have to get down to a single term, we're not trying to do that here. We're just trying to show that they're the same, and that is it.